Welcome to the lecture. In this lecture, we will see NumPy, how to create an array using the NumPy package which is available in Python, how to generate arrays using the built-in functions, and also we will see some of the advantages of NumPy. So, first get started. So, NumPy stands for the numerical Python. So, it is the basic fundamental packages which is available in Python. So, it can be used for the numerical computations. So, if you wanted to calculate a sum or mean or median, so you can use the NumPy package. So, there are different packages also available. So, you have pandas, scipy and all. NumPy is basically for the numerical computations. ND array is a multi-dimensional container of the objects which are of the same type and size. So, it suppose n dimensional array objects, it can be used for processing the multi-dimensional data as well. And also it supports different data types. So, using NumPy we can perform some of the operations. So, the first operation is, so you can calculate mathematical and logical operations on arrays. So, if you wanted to compare two arrays you can do that. So, it can be used for the Fourier transforms as well, linear algebra operations. If you wanted to find a rank or determinant to solve the system of equations, so we can use the NumPy package. And NumPy is also used for the random number generation. So, first we will see how to create an array. Array is basically of ordered collection of elements of the data types. So, the basic syntax is you have to specify the package name. So, which is a NumPy is a package dot array, and inside the parenthesis you have to specify the object. So, first we need to import the NumPy package every time when you run the code. So, I am going to import NumPy as NP. So, it is basically an alias to the package np.array. Inside the parenthesis I am giving the sets of values. So, I am giving 2, 3, 4 and 5 and I am storing it in a variable called x. When you give print type of x it basically returns an output of the data type. Here we have declared it as an array, it has returns an NumPy ND array. So, NumPy n dimensional array. So, when you give print of x, so here 2, 3, 4, 5, so it is an array. So, NumPy can also handle different categorical entities as well. So, we will take a small example. Earlier we had 2, 3, 4 and 5. Now, I am replacing 4 with n. So, I am giving inside the single quotes. So, it has been an array now and I am storing again it in the variable called x. So, when you give print of x, so each value will be converted to a same data type. So, we add n with inside the single quotes, all the other values will be replaced with the single quotes. So, their elements, all the elements will be coerced to the same data type. Here we created arrays using the built-in function, that is np.array, we have given set of values. So, if you wanted to randomly generate arrays, so there are also some of the built-in functions which is available, we will see one by one. First is generate arrays using the linspace. So, numpy.linspace is one inbuilt function which is available. So, it returns an equally spaced numbers based on the sample number. So, syntax is numpy.linspace. So, first is start, it is a start for the interval range, next is stop, end of the interval range, next is num. So, number of samples to be generated. So, if you wanted to generate 100 samples, then you can specify the num is equal to 100. Next is D type, type of an output array, return step. So, the last one is what it does is it returns a sample and as well as a step value which has been incremented. So, we will generate an array B with the start value of 1 and stop value of 5. So, here np.linspace, start value 1, stop value 5, num is number of samples to be generated. So, here I wanted to generate 10 samples. So, next one is the endpoint. So, if you wanted to include the last value which is 5 or not. So, if you give endpoint equal to true, 5 will be included in the samples. Restep equal to false. So, if you give false, it returns only the samples and not the increment value. So, when you print the output, you will be getting 10 samples. So, first value is 1, second value is 1.444, 1.88, 2 and last value is 5. So, if you do not give endpoint equal to true, 5 will not be included in the samples. So, this is it basically returns 10 samples and the last value has been included in the samples. So, we will take another case with 3 step is equal to true. np.linspace, the same start value, stop value, number which is the number of samples, endpoint equal to true. So, till this it is the same command. Here in the last one, so I am given return step equal to true instead of false. So, the output will be first value 1, 1.44, 1.88 till 5 will be the same output. So, in the last case when you see, so we have got a 0.444, this is basically an increment value. So, if you give return step equal to true, it basically returns the samples as well as the step value in which it has been incremented. So, next is if you wanted to generate arrays based on the step value, we can use the arange command. So, numpy.arange, it returns the equally spaced numbers based on the step size. So, the syntax is numpy.arange, start value you have to specify which is in start of an interval range, stop value and which is basically an end value and then step size. So, in which you wanted to increment it. So, we will generate an array with a start value of 1 and stop value of 10 and also the increment value is step size is 2. So, our command will be np.arange, start value is 1 and stop equal to 10 and step is equal to 2 and I am storing it in a variable called d. So, when you print d, so you will be getting an output of 1, 3, 5, 7 and 9. So, which means, so the first start value we have specified as 1. So, in steps of 2 it has to be incremented, right. So, 1 plus 2 it will be 3, 3 plus 2 5, 5 plus 2 7, 7 plus 2 9. So, our stop value is 10. So, after that it will not be able to increment it. So, it returns the 5 samples. Let us say if you wanted to arrays filled with only with ones. So, you can use a command called numpy.ones. It returns an array of given shape. So, if you specify the shape, number of rows and number of columns, it returns an array fully filled with ones. So, the syntax is numpy.ones, shape which is an integer or sequence of integer, d type which is basically the data type. The default one always is float data type. So, when you give np.ones 3, 4 which means 3 stands for rows, 4 stands for number of columns. So, it has generated an array with 3 rows and 4 columns fully filled with ones. So, you can similarly you can also generate arrays using zeros as well. Numpy.zeros is a function. So, it returns an array of the given shape. So, if you specify the shape size, that is dimensions, and then so it returns an type filled with zeros. The syntax is numpy.zeros, shape again which is an integer or sequence of integer, d type which is basically a data type. So, the default is always float. When you give np.zeros, 3 stands for rows, 4 stands for columns. So, when you see the output will be 0 dot which is an float value. So, you can also change the data type as well. So, you can specify in the np.zeros 3, 4 and then you can specify the data type, it can be an integer as well. Let us say if you wanted to generate random values, if you do not want to start a value from 1 to 10 or 1 to 100, you wanted at random values, then you can use the random.rand function which is available in Python. So, numpy.random.rand returns an array with the specified dimension with the random values. The syntax is numpy.random.rand, shape can be an integer or sequence of integer. So, np.random.rand, so I wanted to generate 5 values. So, it randomly generates 5 values. So, the array basically, so the first value is 0.2564, second one is 0.68, third one is 0.8131, fourth one is 0.7665, 0.999. So, it has been randomly generated 5 values. So, if you specify the number of rows and columns also, you can get the random values. Let us say if we wanted to generate an array of random values with 5 rows and 2 columns, you can specify that as well. So, np.random.rand 5, which basically stands for 5 rows and 2 columns. So, it has been created an array with 5 rows and 2 columns and it has random values. So, first value 0.605, second one is 0.3855, 0.08 and the last value 0.702290. So, it has been randomly generated values. Next, if we wanted to generate arrays using the log space as well, using the logs, then you can also do that. So, the numpy.logspace, it returns and again equally spaced numbers based on the log value which you specify. So, the command is the numpy.logspace start, you have to specify the start value of the sequence, the range, stop value, number of samples to be generated. So, the default in this case is 50 and then you have to specify the endpoint. So, again it is binary, true or false. So, if you true, the last sample will be included in the output. Base, the base value which you wanted to give, the log base value. The default is 10.0. D type, type of the output array. So, we will generate an array with 5 samples, the base value is 10.0. So, I am taking the default value. So, the np.logspace start value is 1, stop value is 10. So, if you wanted to generate 5 samples, you have to specify num is equal to 5 and then endpoint equal to true, which means the last sample has to be included in the output array and then base equal to 10.0. So, if you do not specify base is equal to 10.0, it is an automatically it takes 10.0. You can also specify the different base as well. So, it returns the 5 samples. So, the first value is 1.000 e power plus 01 and the last value is 1.000 e power plus 10. So, it returns the 5 samples in the array format. Let us look at the some of the advantages of NumPy. NumPy supports the vectorized operations. Array operations, they are carried out in C in the backend and then they are executed in Python. So, NumPy performs faster than the list. So, first we will look at the speed. So, timeit is a module which is available in Python. So, it can be used to measure the execution time, which is basically a runtime for the snippets of codes. We will take an example. So, we will compare the processing speed of a list and as well as an array using the addition operation. So, the first example is I will create a list using the range. So, range of 1000 and I am storing it in a variable called x. When you give timeit of sum of x, it returns an output of 17.7 microseconds. So, next we will create a NumPy array. We will also calculate the runtime speed for this as well and then we will compare which one is faster. So, creating a NumPy array. So, the x is equal to range of 1000, np dot I am converting into an array and I am storing it in a variable called y. So, when you give timeit of np dot sum of y, it returns an output of 5.41 microseconds. So, the array works faster when compared with list. So, this is the first advantage of NumPy. We will also look at the storage pair for both list as well as the NumPy array. So, we will compare the list x and array y from the previous example and we will calculate the memory used at the runtime. So, get size of, which is a built-in function, it returns the size of the object in bytes. So, the syntax is sys, it is a built-in package, it is used for system specific parameters. Dot get size of, inside the parenthesis specify the object. So, it basically returns the size of the objects in bytes. So, you have next one is item size, it returns the size of the one element of the NumPy array. So, item size it can be used for the NumPy array. So, the syntax is numpy.nd array, which is n dimensional array dot item size. First we will calculate the storage space for the list and then we will do it for the array. So, the size of the list, it can be found by multiplying the, first we will take the size of an individual element and then with the number of elements in the list. So, for that we need to import a package called import sys. So, it is for system specific parameters. So, using this sys dot get size of first one, so 1 into element multiplied with length of the elements in the x. So, it returns an output of 28,000. For the list it took 28,000 bytes. Similarly, we will calculate for the array as well. So, the size of an array, it can be again found by multiplying the size of the individual element with the number of elements. So, if you have 10 number of elements, so what it does is it first calculate the size of one individual element with the 10 elements in the array. So, if you give y dot, so the y is an array which we have stored already. So, y dot item size into y dot the length of the size, which is the number of elements present in the array. So, for this it returns an output of 4000, which means 4000 bytes. For list it took 28,000 bytes, for array it only took 4000 bytes. So, this is another advantage of using the numpy compared to list. So, let us summarize. So, first we saw how to create an array and we also saw some of the built-in functions to generate arrays. First one is linspace. So, it generates arrays based on the sample number. You have to specify the start value, end value. Next we also saw arange. So, arange, it generates arrays based on the step size. So, it is an increment value, and we also saw ones. So, ones it basically generate arrays fully filled with ones. So, if you wanted to fully fill with zeros, so numpy dot zeros you can use. We also saw how to generate random values. So, random.rand, it generates random values. Next we also saw log spaces. So, you can specify the base value and you can generate arrays. We also saw some of the advantages of numpy. So, the first one is speed. We created an array, we also created a list, we compared both, and we also saw the storage spaces. We also saw some of the advantages of numpy. So, we saw how to calculate the speed and we also saw how to calculate the storage space. So, numpy uses the less bytes and also the less time to run the snippets of codes. Thank you.